This lesson is about product rule. Product rule is another rule which allows for differentiation of more complex functions. Let's just have a look at what a world looks like without the product rule. If I'm trying to differentiate this function, I can do my bracket expansion. Okay, shouldn't have to tell you how to do these expansions. I can collect my like terms, and then I can just differentiate by rule all of these. Okay, good to go. That's what it looks like without product rule. However, if we have a function that we can write as two functions multiplied together, then the derivative is u dash v plus uv dash. So let's see how this works and make sure that it works. The way we'll do this is I'll identify this as u and identify this as v. So I know that u is 2x plus 1. I know that v is 3x plus 7. U dash is the derivative of u, which is 2. V dash is the derivative of v, which is 3. So now I have all four of these things which I need to apply the product rule. So the derivative is u dash v plus u v dash. And I simply substitute these things in. So u dash is 2 times v, which is 3x plus 7, plus u, which is 2x plus 1, multiplied by v dash, which is 3. Okay, I probably just leave it like that, but I could also expand and simplify. 6x plus 14 plus 6x plus 3, which will get me 12x plus 17 as my derivative, okay, which is the same as I got by doing expansion. So what that means is that expansion and product rule are the same. They'll give us the same outcome. There's some instances where product rule will help us out. For example, in this example where we have u and v with 3 terms in there, if I was to expand this, I'd probably make some mistakes doing my FOIL triple expansion. So instead, I'll make this u multiplied by v. I'll list what u is. I'll list what v is. That should be 3x squared. So we'll use 3x squared all the way. I'll find what u dash is. And find v dash. I shouldn't need to explain these differentiations. And then the derivative will be, I'll use the same notation, u dash v plus u v dash. Okay, so I can put in u dash 35x to the power 6 plus 24x to the 7 plus 1. V is 3x squared plus 8x plus 9. And then plus u, 5x to the power 7 plus 3x to the power 8 plus x plus v dash 6x plus 8. Okay, so we can see that we've pretty much used all 4 of these at some stage. So there was u, there's v, there's u dash, and the one that's not highlighted is v dash. Okay, use all 4 elements of it to apply the product rule. And I'll just leave it the derivative like that, okay, as y dash. Okay, turning over the page for some further examples where it might be a bit more complex. Okay, so for example, if I have a quotient, if I have 2 things divided by each other, it might not look like I can use product rule because doesn't seem how I can write this as u times v. But the little trick to get around this is I rewrite my function as the numerator multiplied by the reciprocal of the denominator. Okay, bring it up and give it a negative power. So this is u, and this is v. So u is x plus 8, v is 2x plus 7 to the power minus 1. So u dash is 1, and v dash is negative 2x plus 7 times the derivative of 2x plus 7. This is the power minus 2. Okay, so I get v dash is minus, so it's the power minus 2 times 2, and I can rewrite it a little bit neater. Minus 2, 2x plus 7 to the negative 2. Okay, so at this point I won't bring the power down and make it positive. Okay, so derivative is u dash v plus u v dash. Substitute in all these values. 1 times 2x plus 7 to the power minus 1 plus x plus 8 times minus 2 to the power 2x plus 7 to the minus 2. Okay, so we want to see if we can do some simplification or factorization here. We'll see that we have a common factor between both of these of 2x plus 7. So what will happen is 2x plus 7 will come out the front as highest common factor. Okay, but we always choose the smallest number as our power. Like for example, if I was trying to factorize this guy, I'd take the y squared as the power. Okay, the smallest of the two. The smallest of these two powers is negative 2. Okay, and the tricky part is thinking about what I'm going to write as my power here. So in these examples, I need to make sure that the two powers add to what I had originally. So the power I'm going to put here is such that minus 2 plus something gives me minus 1. Okay, so this power here is going to be 1. And you'll find when you multiply these two, you'll end up with negative 1. Okay, and then we can clean up this side, ends up as minus 2x plus 8. So 2x plus 7, still to the power minus 2. Inside the brackets, I've got 2x plus 7 minus 2x minus 16. The 2x plus 7 to the power minus 2 is going to come down the bottom and be given a positive power. And this other stuff that's left up top, we'll just collect like terms. So 2x minus 2x is nothing. 7 minus 16 is minus 9. Okay, so that would be my derivative. So you'll see in here, I've really probably skipped ahead a lesson because I use the chain rule inside the product rule. Okay, but we eventually get there. Okay, if you are doing this question, you'll get like, I don't know, 4 out of 5 marks probably for getting to this point. Doing this algebraic simplification will get you the 5 out of 5. Okay, final question. Find the derivative of this one that has 3 terms. So you might be thinking u, v, w. Nah. Okay, we've got 2 options. We can either say that this is u and this is v. This is option 1. So u is x, x plus 1, and then when you're finding u dash, it'll be product rule again. Yeah, that's one option. I don't particularly like that option, just because there's an easier way. Okay, option 2, which is the preferred way, would be to just expand that first set of brackets So I'd end up with x squared plus x multiplied by 2x plus 3. And then I can set this as u and this is v. Okay, should be able to find u dash and v dash pretty easy. And then I can go ahead and solve for the derivative. Okay, since they're pretty low terms, we'd probably expand and simplify. If there's any powers here, I wouldn't even bother expanding and simplifying, but since this is relatively small, I'll expand these first set of brackets. And the second set of brackets. So I should be able to just collect like terms here. And I'm good to go. That was pretty easy. Doing another product rule in here, I'd probably end up being confused. Okay, so turn the page, have a go at these questions, and remember it's just all about practice, 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 practice.